video I have shown the problem up to sixth number on numbers theory. So now I will start from the seventh problem. So seventh problem says find the LCM of two numbers given with the prime factors. The prime factors are written as 2 into 2 into 3 into 3 into 5, and the number is y1, and the second one is first one is x and the second one is y. That is written as prime factor, this one. This is very simple, but to remind the concept of LCM, LCM says you have to take the factors with the highest number of power. Means wherever you find the factors, means prime factor. This is 2 is one prime factor. If I consider first as 2, though out of these two numbers, there I can get 2 of 2, means 2's power 2. That is maximum. So I have to take 2 square out of these 2. So now this 2 is eliminated. Then after 3 I can see another factor, and now in the second number I get 3 numbers of 3. So I will consider this one, not this one, and another prime factor, which is 5, but this is not available here, but still I have to get the maximum one. So maximum is 5 to the power 1. So your answer should be 4 into 27 into 5. So if I calculate 20 into 27, 27 to the 54, then accompanied with 0, so that the answer will be 540. So this is your answer for 7th problem. Now come to the problem number 8. So 8 says if a alphabet A represented by is representing a number represented by the prime factors P into Q again, then R into S, another number, and B is another number which is represented by P into Q into R, then GCD of A and B. You have to find what is the GCD of A and B. Now in earlier cases the problem was to calculate LCM, but this time it is GCD, that means HCF. So we know that for HCF we have to consider the common factors only, not all factors. We have to consider the common factors. So common factors, and that to the lowest degree. Okay, so power would be where it is minimum, it is coming. So I can see the factors is coming P. Now out of this only one P is available, so I will consider for HCF one P only. So P is gone. Now Q is another factor, but here two Q's are coming, here also two Q's are coming. So there is no problem taking two Q's together. Then after R also common, so R, and the power is 1, so I can take R. But S is not common, so this common things has to be there. See, you have to stress highest common factors. So highest common factors will be formed by taking all common prime factors. If I multiply all common prime factors, the result will give you the highest common factors. So you have to stress on this number, highest common. Only thing is that it has to be common, and here there is no ambiguity, but in case let's say there on one another q are coming. So in that case, choice would be where the minimum number of q is available, that we have to choose the minimum power of the factor. So that would be the common, because higher if we take, the another q will miss in the other number, so that would give you a wrong answer. So we have to take the factors with a lesser power this time. Okay, so this is your 8th problem. Going to the next, that is 9th problem. 9th problem says the HCF and LCM of two numbers is 10 to the power 12, then the other number what is the other number? You have to find the other number. So the HCF and LCM of two numbers are this one. So in this case, you have to use that relation where we know that HCF into LCM is the product of two numbers. If LCF, if you know the HCF and LCM of these two numbers A and B, then so if we multiply HCF and LCM of those numbers, then that will be equal to the product of those numbers, So now if these are known, one number is known, so other you can calculate. So let's say A is this one, so B will be HCF and LCF of two numbers is the HCF and LCF of two numbers is then the number. Now in this case, the both HCF and LCM are same. So the probability of, because these are, let's say this is x, this is also x. Now A into B is x into x. Let's say I am taking it y to distinguish the sign. So this is y into y. So if A, then the other numbers is HCF also two numbers is, oh sorry, I missed something, I'm written wrong, is 10 to the power 10. Okay, let's write the thing first correctly. I missed some. One number is R. Numbers are two numbers are 10 to the power 10 and 10 to the power 12 into 7 cube if one of the number is 10 to the power 12, then other number. Sorry, I missed one line, so that's why some confusion came. The problem that I am assuming to be, and I am explaining some other thing that may arise in later example also, is there is a kind of thing that may arise, because where the LCM and HCF of two numbers are same, what would be the number? So that is a different question, but this case the HCF and LCM of two numbers is given this one and this one. So it is very easy, as you know that HCF into LCM is the product of those numbers A into B, let's say two numbers. So you know all this HCF LCM, you know you know one number, so B would be HCF, that means 10 to the power 10 into LCM is 10 to the power 12 into 7 cube, then the number is 10 to the power 12, I say. So if I cancelled out, it will become 2 become 10, so the other answer will be, other number will be 10 to the power 10 into 7 cube. So that will be answer. This is a very easy sum because you know the relation, so only thing is that to put the value and calculate the other number. Okay, so this is your 9th problem. Okay, so as I was discussing the problem, this may arise that if LCM and HCF of two numbers are same, then what would be the numbers. So as I explaining, if LCM and HCF, let's say these are represented by y, the both are y and the numbers are a into b, let's say I am taking it a different number, so a into b is equal to y square. So you can understand, if it is y square, and it must be, and a and b value must be same with y square, because y square is achieved by multiplying y into y. Okay, so the numbers cannot be a different number, rather a and b must be, if it has to be equal to this y square, a and b must be equal. So the number for which the LCM and HCF must be same, those number must be equal. Otherwise, two numbers multiplying with a y square, it cannot achieve. Okay, so a and b, if I say that what is a and b, so a and b here I have to take y. Let's say one example I have taken, numerical example. Let's say y square is equal to 3 square. Okay, then what will be the value of y? Y square is equal to 9. So 9 only can be achieved by 1 into 9 or 3 into 3. So the probability of getting LCM and HCF equal with these two numbers 1 and 9, I cannot get equal LCM, because if I take the LCM of that, if I try to factorize that, okay, so I will get LCM one, this one, but if I want to consider HCF, so individually one has only one factor 1, 9 has 3 into 3 into 1, so common is only 1, so 1 and 9 cannot be equal. So only possibility is that if two numbers are same, then only for 3 and 3 your LCM will be 3 and HCF also to be, because there the common factor is 3, so HCF and LCM will be same if the numbers are same. Understood? So this I am trying to discuss in the earlier, but earlier problem is different. So this is one kind of problem that I have discussed. If in case the LCM and LCM of the both numbers are same, the number must be equal. Okay, so this is for now. In the next video I will continue with further problems. Thank you.